Uh, Welcome to Table Talks. In today's video, we're going to see how we get the resultant force of any number of forces that act on a body from a single point. Now, from our question here, they're saying that three forces are applied to a point as shown below. And the point is a point O. Now, the question asks us to calculate the resultant force acting at O. Now, when we are calculating the resultant force, we say the resultant force is a single force that has the same effect as two or more forces. Now, to get the resultant force, we must first resolve the forces acting on the body into two components, that is the horizontal component and the vertical component. Now, the resultant is got from the resultant force is that component force. Is that force that we get from combining the vertical and the horizontal component of the force. So let's look at our solution here. We can look at the solution. We shall begin by saying resolving vertically. Now you remember when we were looking at resolving forces, we said that when we are resolving vertically, we use sine. Now we have three forces that are acting. We have a force of 14 that is horizontal, and that force that is horizontal has no vertical component, meaning its component in the vertical direction is 0. In other words, sine 0 is 0. Now, when we say we are resolving vertically, this one we are going to get the force Fy is equal to, this is 14 sine 0, which gives us 0. Then this is plus. We get the total in the vertical direction for all the forces, plus 6 sine 45, then minus 8 sine 45. Now, here, why am I saying 6 sine 45? We know, if we can remember, and we go back to the quadrants, we say that all the trigonometric ratios are positive in the first quadrant, and then it's only sine that is positive in the second, and then it is tan that is positive in the third, and it is cos that is positive in the fourth quadrant. You remember that mnemonic where I used to say that all students take chemistry. So now here we are in the second quadrant, and it means that our sign here, the value of sign we get in this quadrant, should be positive. Then 8, we are saying negative 8 simply because the 45 in the third quadrant will give us negative. This is the same as 180. It is the same as 180 plus 45, which would give you 225 degrees. If you press your calculator, 225 degrees will give you the same answer as negative sine 45. That's what brings in that. So let us get our answer here. Get the calculator. Here we have sine 65 minus 8 sine 45. And from the calculator, we get negative 1.41 newtons. Now, we have finished resolving vertically. Now, let us resolve horizontally. Resolving horizontally. Now, we agreed that when we are resolving horizontally, we use cos. Therefore, the horizontal component of this force will be equal to, again, that force, that is 14 cos 0, which is 1, and then minus 6 cos minus 6 cos 45, then this is minus 8 cos 45. So again, let's compute. This is 14 cos 0, which is the same as 14. 14 cos 0 is the same as 14. Minus 6 cos 45 minus 8 cos 45. This gives me my answer as 4.1 newtons. Now, you remember we said that if we can condense this diagram of ours, because we said we are supposed to get the two components of the force. Now, when you realize that the force in the y direction is negative, then it means that the resultant force in the vertical direction was acting upwards, and when this is positive, it means it is in the direction of the positive x-axis, then this one is pointing in the direction of the negative y-axis. So this is our angle, and this can be FR, where FR is our resultant force that they wanted in the question. So from Pythagoras theorem, we see that FR, this FR here, or FR here, is FR squared is equal to Fx squared plus Fy squared. Therefore, FR is equal to Fx squared plus Fy squared and the root. Therefore, my resultant force is equal to Fx, this is 4.1 squared plus bracket minus 1.41 squared, the whole thing under the root. So let us compute 4.1 squared plus minus 1.41 squared root of the answer. So this one shows me that the resultant force is 4.34 newtons. But you remember we said that force is a vector quantity that has got both magnitude and direction. So if that is the case, it means we have to get the direction, and the direction from this diagram is given by tan. So when we are getting direction, we say this is tan theta is equal to Fy out of Fx. Therefore, theta is equal to the tan inverse of Fy. Fy was given as a negative 1 point now since it is in the downward direction, we substitute in these values of ours, we substitute them in, and we see what it gives. So we realize that our tan inverse to that is 17.998 degrees. Now, you realize that our Fy was negative, but since we also illustrated on this diagram that was pointing downwards, then the negative is omitted. This one we got it as that. So we had to get the result that we got. Now, we have to conclude, because we said vector quantities, these are quantities that can be described by both magnitude and direction. Therefore, this means that we should describe. So how do we describe here? We are going to describe and say that the resultant force is 4.34 newtons below the horizontal, below the positive horizontal. So the resulting force acts. The resultant force acts at 17.998 degrees below the horizontal. So please make sure when you're answering, you give this conclusion to show that it is true. You're looking at vector quantities. So that is how easily we could go about it. But this has been one way of resolving, and we have gotten these values. Now I want to show you that there is another way we can resolve and still come up with the same result. Let me rub here and we try that method from here. Now, we found out, or we realized that when we are resolving vertically, we use sine. And then when we are resolving horizontally, we use cos. Now, if you are not sure of which trigonometric ratio is positive where, what you can do everything lump sum. So let us put here alternatively. Let us resolve in another way. Now let us begin with the resolving maybe vertically. Now we said resolving vertically, to get Fy we use sine. So this is 14 sine on that is sine 0 plus 6 sine from the angle between this horizon and that is 135. If you can look at that as being a straight line, plus 8 sine from here. If we take positive angles which are taken in anti-clockwise direction, this will be 180 plus 45, which will be 225. Now when we press our calculator, we come up with 1.41 newtons. Then let us also resolve vertically. Fx will be equal to 14 cos 0 plus 6 cos 135 plus 8 cos 225. Now here we shall also again get 4.1 newtons, and we proceed as before. So this is also another alternative way of doing what? Of resolving. Thank you.